Today we are going through to try this lab sheet C205 on extracting the executable from the PCAP file. Okay, so for this lab sheet, we will be given a PCAP file. So this PCAP file contains a malware called NIMDA. Okay, that's why the file is called NIMDA. So as part of the job as a security analyst, right, we look at a lot of logs. Okay, so sometimes the logs contain interesting transaction on the internet, on the network. From the packet level, we can actually extract some of the interesting things like the malware executable file. And then after that, we can do some forensic analysis and so on. So this is what we are going to do for this lab. For this lab, we are going to use the CyberOps VM. So we are going to use CyberOps. So I have started my CyberOps here. Okay. So what we'll do is we will use the PCAP file, okay, to do some basic extraction as well as analysis. We'll analyze the TCP frame. So let's go over to the terminal. Terminal over here. Then after that, it will look something like this. Make it slightly bigger. Okay, so next I'll go over to the files folder, cd sheet. Oh, I'm already in the PCAP file. Okay, so I'm already in this folder, lab support files/PCAPs. So from this folder, what I'll do is I will check the content lists. And this is the file I want to analyze. So next, I'm going to run the Wireshark with the file. Okay, one more thing, remember, is there's a @ sign at the back. Okay, so remember to include the @ sign. Okay, why do we need the @ sign at the back here? Okay, why do we need the @ sign? Because usually when we run the app in Linux, the program will execute, and then after it finish running the execution of the program, it will stop and then go back to the terminal or go back to the OS. So when we put the @ symbol behind, right, we are telling the Linux to say run this command, okay, and then stay there. Don't get up. Just stay there. So this is what we're going to do. We're going to run the Wireshark later, and then the program will kind of like continue running in the foreground or in the background. The background? Yeah, background. Yeah, and we'll send to the background. So let's try that. So Wireshark nimda.pcap and press enter. You will launch a Wireshark. If you go back to terminal, you will see this number over here. So this is the I think the process number, process ID. Okay, now next we go back to Wireshark. So from the Wireshark, we are going to try and analyze and capture the information. If you noticed on the internet, on the network, there is one of the packet. There are a number of TCP protocol over here. So what happened is, if you notice one of them, can you see this number 4 packet? There's this very interesting thing over here. So this is usually what we are trying to look for. Okay, while we analyze the Wireshark we try to look out for interesting things. Okay, so this is one of those interesting things that it may seem in so-called suspicious EXE file. So EXE file or the executable file for Windows. So usually when we run the Windows program, we double click the exe file to run it. So in this case, we notice that inside one of the transaction, this particular packet is trying to fetch exe file. So get is a command, a HTTP command used by the web server to usually download something or to get something from the server. So in this case, we see that the user is at this address, right, is trying to download as Windows executable file. So this may seem interesting because why is the user downloading a Windows executable file? Okay, and true enough, later you'll see this Windows executable file is actually a file with a malware. Okay, so if the user downloaded the malware, most likely it will execute and also spread the malware in the host PC. Okay, so that's what we are going to do. So select the form packet, and then we are going to look at the information using follow HTTP. So let's go over to the Wireshark here. Select the form packet, right click, and look for follow TCP stream. Okay. Once I click, I will see this appear on the screen. So what is interesting about this stream is this. On this stream, you will see a couple of stuff that okay, the first part on the top here, this is the header. That means your IP packet, when you actually send to the browser, there's the header of the file. Okay, so on the header of the file, the HTTP header, you have all this information like it's a GET request based on HTTP 1.1 protocol. The requester address is this one, 202.133. Requester port is 6666. So these are the important things we usually see. And how it's requested is requested using the wget command. Wget is Linux executable program. It is basically a program to download files. So these are the things that we see over here. Get command HTTP 1.1, wget, the host address, and the host port. Okay, so these are the things that we usually want to take note of. Okay, the next thing we see at the bottom, at the middle here. Okay, this is the response. So this one on top here, the one on top here is the request. Okay, so this is the HTTP requests. That means from the hosts. That means this one is the destination. This one is the request, and this is the HTTP response. So inside the HTTP response, you can see the following. First of all, the web server is Nginx web server 1.12. Nginx is one of the software. It's a web server software. And the request is successful. 200 is HTTP status code for the successful transaction. Date of transaction also here, 2nd May 2017 to 2:26 p.m. afternoon. Of course, there are a few other things that you can see over here. So basically, this is the response that we get from the web server. Then finally, if you scroll below, you will see a couple of things that is dot dot dot. So all this information in dot 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 is because they are in non-human readable form called binary. Okay, so binary format means you are unable to see it because it's not in alphanumeric characters. Okay, aside from being a binary file, usually binary file means it may mean that it is a executable file. That means can it be executed in the operating system? Nobody knows. But over here, there are some things that we can see. The first one is the header of the binary file. The header is actually this part over here. Is this part. Let me use another color. So this is usually the header. So in this header, you can see the header is having a start MZ. So MZ is a notation for Microsoft executable. So it's a Microsoft executable file. In fact, if you see this command, you can also see this. Okay, this program cannot be run in DOS mode. What is DOS? I'm not sure whether you all have used it before. About 20, 30 years ago, no, 30, 40 years ago, when the computer was first created, the first computer was IBM. And then after that, IBM decided to ask Microsoft, which is Bill Gates, to create an operating system. So the first operating system to run on the first personal computer is called DOS, which stands for Disk Operating System. Okay. So after that, which is about 40 years ago, about 1980, I think that was 1983 or 1984. So the first operating system, DOS, was created. And then, of course, later on, more and more new computers and the computer OS changed. After DOS came out, a few generations later, it evolved into this operating system called Windows, which is what you are using now. The current iteration of Windows operating system is Windows 11. So before we have Windows, we have the father of the Windows is called DOS, this operating system. So in this case, this comment inside this binary file says this program cannot be run in DOS mode. It means that you cannot run it on the original, the DOS prompt, okay, the command prompt. So it means that it is a Windows program with the GUI, okay, graphical user interface, or at least in the Windows 32 API format. Windows 16 or Windows 32 form. Okay. The rest of it we can't read because it's all in gibberish, is binary. So that's what we can see over here. Okay. You can scroll down and see some more. Okay. You can see some other things inside the binary, like for example, this MSBC RT, kernel 32 RT, NT, DLL, all this stuff. DLL stands for Dynamic Link Library. Okay. It is a file, or actually a set of executable that are separately packaged inside the program. Okay. It is just another set of programs that is running. So whenever we see a DLL file, right, we will know that this whole bunch of executable is a Microsoft Windows executable, because DLL only appear in Microsoft Windows. For Linux, for Mac OS, we don't have DLL. Okay, so that's why by looking at the content of the binary file, we more or less can guess what is being sent across the whole channel or the whole file. Okay. Towards the end, if you can see, you can actually see a few more things at the back. Okay. So this is basically the whole stuff that we see over here. Okay, let's go back to the lab sheet. Okay, so there are some questions they ask, so we'll try to answer them now. What are those symbols shown in the follow TCP stream window? These symbols over here, these are basically your binary windows, binary files, binary data. Okay, so these are binary data. They are not connection noise. There are a few readable words spread among windows. Why are they there? I think they are talking about this one. Okay. So this question, why are they there? I think let's try and answer it. This shows the file is Microsoft Windows program, executable program. Okay, so this is my answer for this part. Okay, let's go on. Okay, there is a challenge question. Despite the nmap limit executable is not the famous word. Security reason, this is another executable file, rename, blah, 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 blah. Okay, can you tell what executable is it? Okay, long story cut short, it means that this is not the real malware. It's actually another Windows executable. Because the original Nimda is a worm. If you remember what is a worm, the worm is actually a malware that will replicate by itself. So it will spread like COVID. Okay, so for this case, this is not the real Nimda worm. So it's actually another program. How do we actually know what is suitable in this? Okay, let's check. So if we go back to this one, let's look at the data stream. I think somewhere inside there, we have Garfield signs actually. If you scroll below and now, you should be able to see this thing over here. I don't know whether you can see it. Let me try and find it and I'll show you. Okay. Yeah, sometimes we have to be patient because there's a lot of things that can come up. I also don't know. Oh, I think it's the end. Or not finish it. Shit. Here we go. Yeah, here. Can you see? So right at the back, somewhere around here, can you see there's a whole bunch of stuff here. Okay, already they tell you it's a Microsoft corporation, so it's a Microsoft program. This program is called what? Kind of, it's written something. Oh dear, God bless you. Yeah, I think it's Windows Command Process. This one, sorry. Internal name. So this is the name of the program, CMD. So CMD, if you remember, this is a command prompt program. So this means that this executable file that's embedded in this PCAP file is actually a command prompt exe, command.exe. Okay. So it's not the real world, it's a command.exe executable file. Okay. So let's try write this down. So the program is actually .exe executable file. Okay, let's go on to part 2. Download the file from PCAP. So we are going to download the malware or the executable file. So let's go over to this file export object, HTTP, inside Wireshark. So let's close this. With this packet selected, so let me go back. Okay, let's select this packet here. With the packet file selected, I go to File, Export Objects, HTTP. Can you see? It's inside here. Export Objects, HTTP. So let's do that now. So export objects HTTP, and then this is what you will see. There is one file that we're trying to export. This is the file called W32 Windows 32 nimda.m.exe. So let's click save, save somewhere. So of course you can save it somewhere. So let me save it maybe on my desktop now. Okay, I save it on my desktop. So after I save it on my desktop, I should be able to see the file. So let me go to my, oops, let me go to my file manager. On my file manager, if you navigate to your desktop, you should be able to see the file you just extracted. This is the nimda.m.exe file. So this is the file that we just extracted from the PCAP. Okay, the set of traffic packets. So that's part quite straightforward. We have done all this. There's one question in the no, in the lab sheet. Let's try and answer. Why is W32 nimda.m the only file in the capture? Why? Because there's only one file. Why do they ask this kind of question? Not sure. Oh, there's only one file inside, so we just extract this file. Okay, never mind, I'll just leave it. So after we save the file, we should be able to see the exe file in our directory, which is shown over here. So the file has been extracted. Okay, then next, towards the last part, okay, we can actually use the file to do some forensic analysis now. So a very basic way is to use the file command. Okay, so in this case, we just type file w32.nimda.m.exe. So let's do that. We go over to our terminal. Okay, so for my terminal, remember my file is inside the desktop. So let me just cd space curly home desktop. In case you forgot, this curly thing means you go back to your roots. Okay, this is convention in Linux. So I go back to my desktop. I should be able to find the file which I extracted just now, which is called the ww2 nimda.m. So let me just quickly check the file, W32, let's enter. So this file shows that this is a PE32 plus executable meant for x86 and 64 Windows platform. PE stands for portable executable. So it is a term for basically a executable file for Microsoft Windows. I think it's also built for 64-bit Windows. So that's why you see this thing over here. Okay, so that is how we can do the simple forensic check